In this video, we will be solving a system of equation using the steps that we've already learned. So first off, we have a glass blower that can form 8 simple vases or 2 elaborate vases in 1 hour. In a work shift of no more than 8 hours, the worker must form at least 40 vases. We want to let S represent the number of simple vases, the hours forming simple vases. We want E to represent the hours forming elaborate vases, and we're asked to write a system of equations involving the time spent on each vase. So the first part, step 1, we need to define our variables. So in the problem, they've already told us, let S represent hours forming simple vases. And we want to let E represent hours forming elaborate vases. So we can write our inequalities here using those variables. So we know that we have 8 simple vases, so 8S, plus 2 elaborate vases, so plus 2E. So we can make 8 simple and 2 elaborate. And we need to make at least, so greater than or equal to, 40 vases. Then we also have the number of hours spent forming simple plus the number of hours spent forming elaborate can be no more than, so less than or equal to, only 8 hours. So we want to be able to write these inequalities in terms of x and y so that we'll be able to graph these. So let's look at our variables and have them be represented using x and y. So let's let S represent x, okay, in terms of graphing. And we'll let E be represented by y. So if we rewrite our inequalities, taking into consideration x and y now instead of S and E, we have 8x plus 2y is greater than or equal to 40. So all I'm doing is replacing S and E with x and y so that we'll be able to graph. Then with our second one, we have x plus y is less than or equal to 8. So these are the systems that we're going to use. These are our inequalities that we're going to be using in order to figure out the remainder of this problem. Now we are asked if the glass blower makes a profit of $30 per hour worked on simple vases and $35 per hour worked on elaborate vases, write a function for the total profit. So we have $30 per hour for simple, and we have $35 per hour on elaborate. And we're asked to write an equation or a function for profit. So step 2 is to write our objective function. So we want to write our objective function similar to using function notation. So we're going to have f of x comma y, so we're taking into consideration simple vases and elaborate vases, equal to, it costs $30 per hour for simple vases, so we'll represent that with 30x, plus $35 per hour for elaborate, so 35y. So this f of xy is going to represent profit. So now that we have our systems of inequalities and we have our profit function, we can move to step 3, which is writing our constraints. So first off, we know that we can't have a negative number of hours. So x must be greater than or equal to 0. Same thing with y. We can't have a negative number of hours representing our elaborate vases, so y must also be greater than or equal to 0. Our next constraint is going to be our top inequality. In order to create 8 simple vases and 2 elaborate, and we have to make at least 40 of those. So we have 8x plus 2y greater than or equal to 40. And our last constraint is our bottom inequality. We only have 8 hours to create these vases. So x plus y is less than or equal to 8. Now that we have our constraints, we can put together a graph. So step 4 is to graph the constraints. And in order to graph these, we want to solve for our intercepts because we know that these are linear. So we just need 2 points and then we can connect our 2 points. So looking at our equations, or our inequalities, one is 8x plus 2y is greater than or equal to 40. And our other was just x plus y was less than or equal to 8. So we can solve for our intercepts. So if we make an xy table, we can solve for when x equals 0 and for when y equals 0. So plugging in x equals 0 here, we have 8 times 0 plus 2 times y is greater than or equal to 40. So we have 8 times 0 plus 2y greater than or equal to 40. So we have 0 plus 2y greater than or equal to 40. Opposite of 2y would be dividing by 2. So when x equals 0, y must be at least 20. Same thing, but now we'll plug in for y is equal to 0. So now we have 8x plus 2 times 0 is greater than or equal to 40. So we have 8x plus 0 is greater than or equal to 40. Opposite of multiplying by 8 is dividing by 8. 40 divided by 8 is 5. So when y equals 0, x is equal to 5. So now we'll do the same thing with our other inequality. So we'll solve for when x is equal to 0 and for y. So we have 0 plus y less than or equal to 8. So therefore y must be 8. Then we have x plus 0 less than or equal to 8. So x would be 8. So now that we have these numbers, we can go to our graph. On our graph, we want to remember which variable we chose as x and which we chose as y. We said simple vases would be represented by x. So simple vases is going to go on our x-axis. We said that elaborate vases would be y. So elaborate vases is going on our vertical or our y-axis. Now we need to use those data points that we got from before, our intercepts, in order to graph. So we said for the first one, when x is equal to 0, y is 20. So we're going to have a point up here at 0, 20. Then we also solved that when x was equal to 5, y was 0. So we can go over x equals 5, y is 0. So that gives us our two intercepts for the first graph. We can connect those 2 points. Now we'll do the same thing with our other inequality. We had when x was equal to 0, y was equal to 8. So we'll have a point up here at 0, 8. And we had when y was equal to 0, x was equal to 8. So we'll have a point out here at 8, 0. Now we can connect those 2 points. We see on our graph that it intersects right here at 4, 4. That point is probably going to be important to us, but we're not going to talk about it right now. So first what we want to do is choose a test point. So we want to pick a point on our graph that we can test in our inequalities to make sure that it holds true. So if we choose the point 1, 1. So if we choose the point 1, 1, we're going to plug that test point in. So our test point is 1, 1. We want to see that that holds true. So we plug in 8 times 1 plus 2 times 1 is greater than or equal to 40. So now that we've tested our first constraint, we have 8 times 1 is 8 plus 2 times 1 is 2 is greater than or equal to 40. So is it true then that 10 is greater than or equal to 40? Well, of course not. We know that that's not true. So on our graph, we're going to shade the region above our inequality represented by 8x plus 2y. So we will shade this area above. Because we've shown that it wasn't true for the point 1, 1. Now we need to test our other constraint. So our other constraint was x plus y is less than or equal to 8. So we have 1 plus 1 is less than or equal to 8. 2 is less than or equal to 8. That's true. So we can shade now on our other graph, our other line, we're going to shade below. Because it was true for the point 1, 1. So now our feasible region becomes the region where both of those overlap. So our feasible region is this region here. So our vertices of our feasible region are these 3 points. So on our sheet, step 5, is to find the vertices of the feasible region. Which is what we just showed. So our vertices, looking at our graph of our feasible region, were 5, 0, 8, 0, and 4, 4. So our vertices are 5, 0, 8, 0, and 4, 4. Now we're going to take those vertices and we're going to plug them in to solve so that we can be able to find our maximum number of vases made of each and what that profit amount will be. So we can create a table. So using our points, so using the point 5, 0, using the point 8, 0, and using the point 4, 4. We're going to plug into our profit equation. So we have our xy values. Our profit equation was 30x plus 35y, and this is going to be our profit. Whatever number we get to be the largest is going to be our maximum profit. So plugging in for this one, we're plugging in 30 times 5 plus 35 times 0. 35 times 5 is 150 plus 0. Our profit would be 150 if we only created 5 simple vases. On the next one, now we have 30 times 8 plus 35 times 0. So 30 times 8 is 240 plus 0, so 240. So if we made 8 simple vases, we would have 240. And on the last one, we have 30 times 4 plus 35 times 4. So we get a maximum profit of 260. So on this, in order to find our solution is going to be the largest number. So our solution is 4, 4, and $260.